Hello everyone, a very good evening. So how are you all doing? Yes, so who all we have here? Sonali Nayak, Ujjwal, Gungun, Mohit. Hi Aradhya. Excited? Yes, I am excited too. Gungun, yes. S. Nagendra. Sonali, good evening Ayush. Hi Thanusha. Hi S. Nagendra. Yes, good evening Sonali. All right, all right. Hi, Yashvi, Kavyansh, Abhirami, Satish. Good evening. Hi, Nitin. Yes. Hey, Ritu. Good evening, Ujjwal. Yes, very excited, Ujjwal, for the last session of this chapter. Wow, wow, wow. I'm so glad that you all are liking these sessions and you're so excited for this session. Perfectly visible and audible. All right, awesome. So there is no glitch at all, so we can start. So my name is Khushbu and a very warm welcome to yet another wonderful session. So what are we going to learn today? As you can see the title of the video, that's rational numbers, but we have already studied rational numbers. So what are we going to learn today? Love this platform and this session. Thank you, Ritu. High-tech game. I am doing really well. Thank you. Yes. So what are we going to learn in this session? Because we have already studied rational numbers. Yes, revision. So we studied rational numbers in different sessions, right? It was bifurcated in different sessions. So what we will do is whatever you learned in those sessions, we are going to learn all that in just one session. So a quick revision of this chapter. So whomsoever has missed the previous session, now it's a good time for you to do the quick revision with me. Yes? Yes, today we will revise and you can note down the important points wherever you feel, because trust me, the notes that you make while learning any concepts, these are very fruitful before your exam day. Right. All right, all right. So let's get started. Yes, are you all ready? Yes. So important questions as well. Some good questions also we'll be solving. Right, all right. Yes, absolutely. It's going to be very useful. All right, all right. So let's get started. So before I start this session, let me just quickly take you through all the topics that I'm going to cover today. So the journey for today's session. So first I'll give you a quick introduction, then we will discuss the properties of rational numbers, followed by distributivity of rational numbers, and then we will quickly discuss how to represent rational numbers on the number line. And we will end this session by discussing how to find rational number between any two rational numbers. Yes. Yes, absolutely, Yashvi. After this session, you all will be pro in rational numbers. I'm pretty sure about that. Right. Right, Sneha. Thank you. All right, so let's get started. But before that, please subscribe the channel if you haven't yet, because you will keep getting notifications about the upcoming sessions, right? All right, so I hope that all of you have subscribed the channel. Yes? Wow, super excited. Yay. All right. So let's get started. So first, as I said, I'll be discussing all these topics one by one, right? So first we will start off with the introduction, a quick introduction about the rational numbers. Yes, I can see that everybody is like already subscribed. Wow, that's amazing. All right, so let's get started. First, let me give you a quick introduction about the rational numbers. So you can see these two kids over here, right? And there's a tree which has got apples on it. So the smart kid is asking the other one, can you count the number of apples on the ground? The other one says, oh wow, that's really simple. There are 1, 2, 3, 3 apples that we can see here, right? So it's really simple for anyone, for anybody would be able to count it out, right? So here, now the other kid says, but wait, tell me, how are we going to distribute these 3 apples between us? Only 3 apples. So the smart kid is saying we can keep 1 apple each, and the remaining 1 apple we can cut into 2 equal pieces. So what does that mean? Each one of them is basically going to get 1.5 piece of apple, right? So the other one says this doesn't look like an integer, right? He's absolutely right. So he's asking, can we write such numbers on the number line which we just discussed? He's talking about those numbers, that 1.5. The smart kid says, yes, absolutely we can do that. Now he is going to explain him how we can show them on the number line. Yes, any doubts? Absolutely, Radhya. That's 1.5, 1.5. It's 1.5 only, right? All right. So he says, all right, so since it is 1.5, 1.5 means each one, as you said, it's 1.5. It's going to lie between 1 and 2. So let's zoom in between these two integers, 1 and 2. Anukriti, I'll answer to that question. Don't worry. All right. So between 1 and 2, we can see here that, let's zoom in. So here is 1, here is 2. What you can see here is that there's so many numbers in between 1 and 2, right? And as I said, 1.5 lies in the middle of 1 and 2, which is nothing but that's 15 by 10 over here. Now you might be thinking, ma'am, you said 1.5 and here you are showing 15 by 10. What is it actually? And similarly, this kid is also confused. He says, oh, it means we can represent any rational number on the number line, because you can see there are so many rational numbers on the number line. Any rational number can be represented, that means. So what are rational numbers actually? Basically, these can be written in the P by Q form. When I'm saying P by Q, here P and Q are basically integers where Q cannot be equal to 0. Please remember this thing, that denominator of a rational number cannot be 0. Yes? Right. All right. So let's take some examples, like we have minus 1 by 2, minus 1 by 4, 1 by 4, 1 by 2. These all are nothing but these are rational numbers only. Right? All right. So the number that I showed you, that was 15 by 10. But we were talking about how to distribute 1.5 apple between the two kids, right? So this 1.5 and 15 by 10, are those both of them the same thing? Yes, because there is something called standard form in rational numbers. So rational numbers are in standard form where P and Q have no common factors, right? And the denominator will be a positive integer. When I'm talking about 15 by 10, this is not in the standard form, because as I said, this is representing Q, P, and this is representing Q. They should have nothing common between them, no common factor. I can reduce this. This is 5 times 3, that is 5 times 2. This is 3 by 2. This is the standard form for this rational number, right? And if you divide it, if you try to convert that in mixed fraction, it's going to be 1.5 only, right? Yes, absolutely, Aradhya. Lowest term. Sonali, standard form, lowest term, or you can say reducing it. They all mean the same thing. Yes. Wow, your maths exam was today, Astha. So how was it? So that's what I'm explaining, the standard form. When I'm saying standard form, you have to reduce it to the lowest form so that there is nothing common between the numerator and the denominator. I hope standard form is clear to everyone now. Quickly, give me thumbs up, smileys, if this is clear to you. Yes. Thank you, Astha. Wow. Amazing. That's nice. Ritisha, no menti today. No. We're doing a quick revision of the entire chapter that we have covered. Rational numbers. Crystal clear? Yes? I can see thumbs up, smileys. Wow. That's amazing, Yashasvi. 39.5 on 40. Wow, awesome. All right, let's move ahead. So till now we learned about what are rational numbers, what is the standard form in rational numbers, and between any two rational numbers, there are infinite rational numbers, right? And any rational number can be represented on the number line. Now let's move ahead. Let's see what these two kids are doing. Now this kid again, he's saying, he again has a question. Are all integers rational numbers? What do you think? Are all integers rational numbers? Quickly, tell me. Yes, no? Don't worry, Aradhya, we'll come up with that as well. But not today. Today we are doing a quick revision. See, before any quiz, it's better we revise everything, whatever we have learned, right? So that we are well prepared for the quiz. Yes? Yes, everyone is saying yes, all integers are rational numbers. And now the other kid is basically explaining him why are all integers rational numbers? Because any integer upon 1, it is satisfying the condition for rational number, right? Because what is the condition for rational number? That it is in the P by Q form, right? And Q should not be 0 where P and Q are integers. So any integer by 1 is also an integer, and denominator is not 0. That's why we can say that all integers, we denote integers with capital Z, are rational numbers. Absolutely, Ritisha. Yes. Absolutely, Ujjwal. So this concept is clear to everyone, right? Awesome. So when we talk about rational numbers, there are basically two categories, I would say. Not really categories, but just to understand this better, we have integers in rational numbers, right? Like minus 3, 0, and 5. We have non-integer rational numbers also, like minus 1 by 2, 5 by 2, 8 by 7. Because we can call them rational numbers, but I cannot call them integers, right? But this can be called an integer as well as a rational number, right? Yes. I hope this is clear to everyone. Thumbs up, smileys. Yes, Anshika? Yes. Quickly. You can write whatever doubt you have. You can post in the chat section. Thank you, Gungun. All right, all right. So I can see thumbs up, smileys and all. So this is clear to everyone. Yes, Shaurya. Yes. Because you can remove the decimal, you will write in the fraction. Yes, it is. All right, all right. So till now we talked about the definition of rational number. We talked about the standard form of a rational number. We saw that all integers can be called rational numbers, right? So we have learned this in detail. Now it's time that you answer a question. So coming up next is a poll question that you have to solve all by yourself. Says which of the following is true? 4 options you can see on the screen. I'm giving you 30 seconds to solve this question and I'm starting the timer now. Quickly tell me what the right answer would be for this. Yes. Sonali, yes. This is also one of the topics. I showed you the flow of the session, right? So I'm going to discuss that, how to represent them on number line. That will be discussed in today's session only. Yes, Anshika, it is. It is because 0 by something, 0 by 1, 0 by 4, you can write anything in the denominator. It will remain 0 only. So it is a rational number. Yes. All right, all right. So what is the right answer? Everybody was saying B, right? Yes, B is the right answer. Every integer is a rational number and we just discussed that. Yes. No, Astha, we are not talking about irrational numbers. See, session is about rational numbers. Irrational is something else, right? How can we consider irrational and rational? That's different. So don't get confused. Yes, so this is clear to everyone. No doubt still here. 0 is rational number or not? Yes, Anshika, 0 is a rational number. All right, all right. Let's move ahead. Let's take a look at what do we need, what are we going to learn next. So till now we talked about the introduction of rational numbers. Now we will talk about the properties of rational numbers. So before I start off with the properties, first tell me why do we need to learn the properties of rational numbers? Why can't we solve it just normally like we normally solve it? Why do we require these properties? Why we need to learn them? Yes. Why do you think we need to learn these properties? Just because they are given in your book? That's why we are learning them? So what is the need? Why is it given in the book? Yes, Dibyanshi, so that we can solve faster, Sonali to solve equations easily, Ujjwal to make calculations simple, Kavyansh, closure property. Yes, yes, Aradhya for ease. Jaspreet to save time, Astha to solve it fast and quickly, yes, Nagendra to solve fast. Absolutely, you all are right. Because it makes the calculation a lot more simpler, saves your time also, right? And this is something that we really need in math, right? To save time. All right, so quickly let's take a look at all the properties that we have for numbers. Closure property, commutative property, associative property, distributive property. One by one, I'll be discussing all of them. Let's start off with the closure property. So what does it say? It says result of mathematical operation on operands belong to the same group as the operands. All right, let's quickly take a look. We will talk about different numbers. Let's say if I talk about whole numbers, right? I talk about integers and rational numbers. So whole numbers, integers and rational numbers, they all hold true, right? Yes. Yes, the calculation, absolutely, right. So currently I'm talking about closure property. So when it comes to addition, it holds true for closure property, right? Yes, they all are closed. Because you add any two whole numbers, you will get a different number, right? Yes. Talking about subtraction, so it works, it is true for integers and rational numbers, but not for whole numbers, right? In that case, it's going to be, it won't be the answer that you are going to get, that won't be a whole number. It's not necessary that it will be a whole number. Let's say 3 minus 4, it gives you minus 1, right? So that's not a whole number. Subtraction is not closed under whole numbers, right? Talking about multiplication, yes, it holds true for all of them, all the group of numbers. Talking about division, so it doesn't hold true for any one of them. Yes, Ayush, for subtraction in case of whole numbers, it is not, right? Yes. Number will be a rational number only, right? Right, absolutely. Yes, Aradhya. Right. So I hope this is clear to everyone. Yes. Division. So for any number when we are talking about, let's say you are doing 3 divided by 4. When you are doing 3 divided by 4, you will get something in decimal, right? Something in decimals. So obviously, again, you're not getting a whole number again, right? It doesn't hold true for it. Similarly for integer also, right? Similarly in case of rational number also. You can pick any example. See, for things to be, these concepts to be crystal clear in your mind, it's better. I know that all of you know this, but it's better if you have any confusion in the mind, please pick up any example. You can try this out after the session also. Pick up any example and then try it again. Yes. Yes, Rita. Which one? Addition, subtraction, multiplication or division? Where you need clarity? On which of these? Yes, quickly. I hope this is clear to everyone. Yes? Subtraction you are saying. For whole numbers, let's say, that's what I'm saying. For whole numbers, let's say you're doing 3 minus 4, you're getting minus 1. So this is not a whole number, right? Minus 1 is not a whole number. Whole number starts from 1, extends up to infinity. 0, 1, 2, 3, 4 and so on like this. Yes, everyone is like, it's clear? All right. I'm on slide 24 only, yes. You want to take a screenshot? Okay. Let's move ahead. Let's quickly take a look at the next property. So now I'll be discussing commutative property. It's a very easy property. It states that we can swap numbers over and still get the same answer. Let's say, if I write that in generalized form, I would say a plus b is equal to b plus a, right? A times b is equal to b times a, right? Let's take a look at all the group of numbers that we have here for whole numbers, integers and rational numbers, right? Commutativity over addition holds true. Yes? I hope this is clear to everyone. Any doubts in this one? Yes, absolutely. Gungun, Abhirami, Ritisha, Aradhya, Kavyansh. Yes. Writing this table will take a lot of time. If you start writing this table, you can do that after the session, because once the session is over, the recorded session would be there on YouTube, right? Then you can again rewatch it and then you can note it down. No, ma'am, no doubt. Not on subtraction. Okay. Talking about subtraction, yes. So you were right, Aradhya. It doesn't hold true for subtraction. So whichever group you pick, whole numbers, integers and rational numbers, right? Great. Talking about multiplication, it will hold true when for commutativity over multiplication. It holds true for all of them, for whole numbers, integers and rational numbers, right? Any example you can pick. Talking about division, doesn't hold true for any of them, right? For division, obviously 3 divided by 4 would not be equal to 4 divided by 3. Makes sense, right? This is simple. We can do it mentally. Hardly takes a few seconds to jump to the answer. Yes, this is clear to everyone. Quickly, thumbs up, smileys or any emojis that you like so that I can move ahead. Yes, Ayush, for division it is a no. Yes, just breathe. Don't worry, Kavyansh, the summary and everything will be provided. Yes. So if, like you are saying, you need the summary, you need the PDFs for these sessions. I hope that all of you have joined our Telegram community. Yes, there you will get all these things. This is clear. Wow, lots of smileys I can see. Amazing. So this was about the commutativity. Right, let's move ahead. Let's take a look at the associative property. So what it states that the result remains the same regardless of how the numbers are grouped. Very simple property. Like a plus b plus c would be same as a plus b plus c. You can see that only we have changed how the numbers are grouped here, right? So a times b times c would be equal to a times b times c. Yes. Joined in Telegram. That's good. That's good, because you will get the notifications also, any new thing that is coming up, or let's say you want the session PDF or you want the summary. All these things would be provided there. Yes. So I hope that all of you have joined the group. Yes. All right. Awesome. So this is the generalized form of the associative property. Okay, let's quickly take a look at this table. When I'm talking about whole numbers, I talk about integers, rational numbers. So associativity over addition holds true, right? But not in case of subtraction. You can pick up any case, right? It will not hold true. All right. Similarly for multiplication also, yes, and for division as well, it doesn't hold true for any one of them. You can pick any example. So what you can do is to have a better clarity. I'm sure that all of you know it. That's why you are saying that, yes, ma'am, it is clear. But still, I would suggest you after the session, what you can do is you can pick up, let's say, I'm talking about associative property. You can pick up any one example for any of these groups, and let's say you're talking about division. You can just try it out with different numbers. Does it work or not? Right? You get a better clarity in that case. Yes. So, Ujjwal, that's a good way to remember this, right? You can remember the table mentally also. That's a nice way of remembering it. Thank you, Yashvi. Thank you, Aradhya. All right, all right. So this was about these three properties, right? So these properties are clear to us. Now let's move ahead. Let's see what these kids are doing. By the way, who is this? Oh, he's saying, are you guys talking about rational numbers? Yes, they were talking about rational numbers. So remember me, I am the identity for the addition of rational numbers. Do you remember the identity for the addition of rational numbers? What is it called really? We have studied that already, right? So what do we call the identity for addition of rational numbers? Quickly. Absolutely, Divyanshi. Yes, right. That's the additive identity or the role of 0. So any number, if added to 0 or 0 added to any number, we get the number itself, right? Like p by q, it's a rational number, plus 0 would give us p by q, or we can write it this way, 0 plus p by q. Same thing, right? So 0 is the additive identity. Please remember this thing. All right, let's move ahead. Now again, he's here. Hey 0, you are reminding me of additive inverse as well. Sometimes I tell you, we get confused. I have seen that students getting confused between the additive identity and the additive inverse. So what additive inverse is really? What is additive inverse? So that's basically, take a look at this. So what is happening here is these two kids are pulling the rope in opposite directions, and that too with equal and opposite forces. This remembers me of my school days when we used to have those tug of war on our sports day. That used to be so much fun. Yes. Yes, Anusha, right. Absolutely, Aradhya. Yes, Ujjwal. So here what is happening is, since they are applying equal and opposite forces in equal and opposite forces, so what will happen? Nothing will happen in this case. There will be zero effect because these forces will cancel out each other, right? So we can say that here x plus minus x would be equal to 0. So that means minus x, I can say it's the additive inverse of x. So if I give you any number, let's say I give you 3, right? So minus 3 would be the additive inverse of 3. So we just have to change the sign. Yes. Yes, Kavyansh, tug of war. Wow. Yes, we are just changing the sign. Just remember this. So this was about the additive inverse. Now let's move ahead. Now who is this? Don't forget my role. I am the multiplicative identity. Okay. So what is it actually? Now this kid is confused. So he says, let me explain you. So multiplicative identity, that's basically 1 is the multiplicative identity, right? So any number multiplied by 1 or multiplied by any number, you get the number itself, right? So p by q times 1 would be equal to p by q, or we can say 1 times p by q. Remember this thing, multiplicative identity, yes. So many times I've seen students getting confused between multiplicative identity and multiplicative inverse, right? So multiplicative inverse or reciprocal, it's the same thing. So let's say a times b times c by d, a by b times c by d is equals to 1, then I can say that a by b is the multiplicative inverse of c by d or vice versa. Yes, that means if I'm multiplying two rational numbers and I get the result as 1, so one of them would be the multiplicative inverse of the other one. Yes. Yes, it's like a reciprocal. Yes, that's another. It's an easier way to remember this. But but maximum times you would come across this word, multiplicative inverse. So you should know this. Yes, absolutely, Aradhya. Nice example. Yes, Ayush. Yes, Dibyanshi. In multiplicative inverse, the sign does not change, right? But in additive inverse, it changes. Sonali, so when we are saying additive inverse, you just have to change the sign. But when we are saying multiplicative inverse, we have to take the reciprocal. No, Dibyanshi, it does not change. Yes, Kavyansh, reciprocal is the multiplicative inverse. Sonali, I have explained it again, what multiplicative inverse is. I hope this is clear to everyone. Quickly. Yes, thumbs up, smileys. Yes, Sonali, yes. All right, awesome. So let's move ahead. Now let's quickly take a look at what topic are we going to study next. So next I'll talk about the distributivity of rational numbers. Let's quickly take a look at this property, distributive property. So in generalized form, how do we write this? A times B plus C is equal to A times B plus A times C. So whatever is written outside the bracket, that would be multiplied by each of the terms which is written inside, right? With the sign along with that. So here, like you can see, we have A times B minus C. Only the sign has changed. So I multiplied this with B first, then I put the negative sign and then A times C. This property, trust me, is very useful because it makes the calculations a lot more simple. Yes. All right. So let's move ahead. So when I'm saying A times B plus C, it could be written as A times B plus A times C. So distributivity of multiplication over addition. How do we write this? A times B plus C is equal to A times B plus A times C. That's how we break it out, right? And distributivity of multiplication over subtraction. I just showed that to you in the previous slide. A times B minus C would be equal to A times B minus A times C. Just remember this. You have to multiply the number, the term which is written outside the bracket with each one of them that is written inside. Do not forget the sign which is given here. Like it's a plus sign here, so plus comes here. It's a minus sign here, so the minus comes here. Yes, absolutely. P. Agesh. It will help you in solving the bigger sums. Yes. Yes. Vice versa, multiplicative inverse. So basically, Gungun, reciprocal. Multiplicative inverse or reciprocal, that's the same thing. Yes, Ujjwal, this property is very useful. Now, we all have seen these properties in our books also, right? But it's better that we take a look at a visual proof of that so that, you can remember this for much longer time. Yes. All right, so visual proof of distributivity of multiplication over addition. We have learned this property, right? Now, let's take a look at the visual proof of this. So A times B, if I represent this with a rectangle which has the dimensions A and B, so area would be A times B. Now we have another rectangle in red color. It has dimensions A and C, so area would be A times C. If I have to add up their areas, I'm going to get A times B plus A times C, and that's how we will represent this figure also. Okay. And if I show it like this, A times B plus C, this is the compact form that I'm showing, right? So in that case, let's say that the rectangles have dimensions as A and B plus C. So in that case, area would be, like we say, length times breadth, it's going to be A times B plus C, right? So that's how it is coming. Yes? I can see that students still are asking about the additive inverse. So I'm repeating one more time. When I'm saying additive identity, so 0 is the additive identity for rational numbers. When I say additive inverse, we just have to change the sign. Like I have 3 by 4, so additive inverse for that would be minus 3 by 4. If I'm talking about the multiplicative identity, that's going to be 1. Yes? And if I talk about multiplicative inverse, we just have to take the reciprocal, right? We just have to flip that number. All right. So this was about the distributive property. Thank you, Ujjwal. Yes, Anshika? I hope this is clear. This is clear to everyone? Distributivity? Yes? Gungun, now understood. Wow. Yashasvi, thumbs up I can see. Aradhya, easy peasy, burger cheesy. Wow. Yes. Associative property and distributive property, these are different. See, when we are saying distributive property, so whatever is written inside, you multiply with each of the numbers or terms that is written inside. But in associativity, we are only just changing their groups. Like I have A plus B plus C, I can write this as A plus B plus C. This is associative property. I'm not multiplying this A with the B and C which is written inside, right? Yes, or if I write it like this, A times B times C, please don't get confused, I'm writing about the associative property. Whomsoever has doubt in this, I can write this as A times B times C. Yes, in associative property, we're only changing their groups, right? But in distributive property, what I'm doing is, whatever is written outside, it is multiplied with each one of them that's written inside. Yes. Anshika, in P by Q form, doesn't matter. See what will happen. Instead of A, B, C, you will have rational numbers over here, like 1 by 2, 3 by 4, something like this. Yes. Sure, yeah, this is clear? Yes, we're only changing the brackets, their position. All right. So this is clear to everyone. So this was about the distributive property, right? Now let's move ahead. Now we will be discussing another topic, rational numbers on the number line, which I think Sonali was asking in the beginning, how to represent them, right? So this is going to be very simple. You just have to remember a few steps. The first thing, is identify the section of the number line on which P by Q, your rational number, is lying. Your rational number could be negative, so it will lie on the negative side. It could be positive, it will lie on the positive side, right? Like this, you have to check first of all. And second thing, you need to see in between which two numbers it will lie. I'll tell you that, how to figure that out. Second thing, divide that section in Q parts. So whatever is written in denominator, you have to divide that section in that much parts. If you have 7 in the denominator, you divide in 7 parts. You have 5 in the denominator, divide in 5 parts. Third step is mark pth division. So whatever is written in the numerator, you mark that division, and that will represent the given rational number on the number line. Trust me, if you have understood these 3 steps, just keep these 3 steps in your mind. So you can represent any rational number on the number line. It's going to be very simple. So let's try out a question for a better understanding. Represent 2 by 5 on a number line. So first thing that I told you, on which section of the number line it will lie. You would say, ma'am, 2 by 5 is positive. So definitely on the positive side. Second thing, the denominator is bigger. Now when the denominator is bigger than the numerator, so definitely it will lie between 0 and 1. So that's how we first identify the section. Yes. All right. Second thing, divide the section in, I said, Q parts. What is Q here? Q is 5 here, right? So I'll divide the section in 5 parts. 1, 2, 3, 4, and 5. Now, so each part is representing 1 by 5, 1 by 5. You don't have to really write that. You just have to divide that in 5 parts. Third thing, P is representing 2 over here, right? So mark second division, and that will represent our given rational number. So that's 2 by 5. That's how you can represent any rational number on the number line. So I hope this is clear to everyone, how to represent the rational numbers on the number line. Yes? All right. What if? Yes, in that case, it will change. All right, let's move ahead. Let's try out another question. Which of the following options represent 5 by 9 on the number line? Now, you quickly tell me, right? So here, first of all, we have to first, so we have to first identify the section of the number line, right? So definitely denominator is bigger. It's going to lie between 0 and 1. We are going to divide it in 9 equal parts. And fifth division, that would be our answer, 5 by 9. Yes? Right side. So everyone has understood how to represent the rational numbers on the number line, right? Quickly thumbs up, smileys, or any emojis that you like. Yes, good evening, Mohammad Anzar Khan. I think you have just joined. And almost, I would say, almost the session. We have just covered the second last topic of this session. So that's okay. Whatever you have missed, the recorded session would be there. You can watch the recorded session later. Thumbs up, smileys, I can see. Wow, awesome. Yes. 9 divisions and it will lie in fifth. Yes. So in that case, when your numerator is going to be bigger than this, right? So obviously number in that case would change, right? So in mentally you can do, let's say it is 1 point something or 2 point something. So if it is coming out as 1 point something, it will lie between 1 and 2. If it is 2 point something, it will lie between 2 and 3. First number you would know, next number would be the other one. Yes, that's how you have to do it. All right, so this was about how to represent rational numbers on the number line. Now let's move ahead to our last topic, which is rational numbers between two rational numbers. So how to find this out? PDF of this. Yes, Aradhya, absolutely. If you have joined the Telegram community, yes, you will get the sessions PDF. Don't worry about that. That's why I was telling all of you, because you have been asking for sessions PDF for quite some time. So all of you, please join it, right? Because a lot more things would be happening on Telegram. Yes. There would be so many interesting Sunday fun day facts as well. Yes, 2 methods are there, right? One is that we make the denominator same, another one is the mean method, right? So let's quickly take a look at this. So first of all, let's say if I ask you how many rational numbers are lying between 1 and 4, okay? So between 1 and 4, take a look at this number line. So you would say that if I look here, I have 2 and 3, right? And both of them have got denominator 1. But if I make their denominator 10, how many rational numbers would I have between them? You can see that 39 rational numbers between 1 and 4 with denominator 10. But now if I change the denominator to 100, so this becomes 100 by 100, this becomes 400 by 100. So I have, you can see that, my God, 399 rational numbers between 1 and 4 with denominator 100. So what is it actually showing? This shows that there are indefinite rational numbers between two rational numbers. So every time I change the denominator, the number of rational numbers between two rational numbers also changes, right? Absolutely, Ujjwal. As we can change the denominator infinite times. Yes. This is clear to everyone, I can see. All right. Yes. So basically, when we are talking about finding out the rational number between any two rational numbers, there are two methods. First one, we're already aware of concept of integers by making the denominator same. Another one is basically we're learning first time in this grade, taking the mean of rational numbers. So first, let's take a look at this question. Find rational numbers between 1 and 5 using the concept of integers that you already know. So what I'll do is, I'll make the denominator same. Let's take LCM of 5 and 2. That's going to be 10. If I have to make this denominator 10, so that I'm multiplying by 2 here. So I'll multiply by 2 in the numerator also. Similarly, here to make it 10, I'm multiplying by 5. So I'll multiply by 5 in the numerator also. So what do I get? I get 2 by 10 and 5 by 10. So here I have 3 by 10, I have 4 by 10. So these can be the required rational numbers between 1 by 5 and 1 by 2. This is simple, right? We already know it. Yes, P. Agash, that's basically you're talking about the mean method. All right, let's move ahead. Now let's try out another question using the other method, the mean one. Find rational numbers between 1 by 7 and 2 by 3 using the concept of mean. As the name suggests, mean is basically average. How do we take average? These are the two rational numbers we have. Let's add them up and divide them by 2. We have to add them up and divide them by 2. That's how you find out that's how we apply the mean method. Okay, let's take LCM and what do we get? We get 17 by 42, right? Yes, I hope this is clear. How to find out a rational number between any two rational numbers? Yes. Easily, see, it's better that you learn this method also, right? Because as you're moving towards higher grades, we need to learn, we should know other methods as well. Because in maths, see, this is the beauty of this subject. There can't be only just one method to solve a particular question. There can be multiple ways to solve it. But we should know them. First, we need to learn them, right? So when you are learning it, it's better that you practice this as well. Yes? So I hope this is clear. Quickly, Gungun, yes. Easy peasy, lemon squeezy, yeah? Yes, Sonali. So what we are doing here is, first we will add them up. You add them up and you divide this by 2. So how will you add them up? You cannot just straight away add them. Why? Because they have got different denominators, right? So we will have to take their LCM. So what will I get? Once I take LCM, I'll multiply this by 3. So I'll multiply by 3 in the numerator also. If I multiply this by 7, I'll have to multiply with 7 also in the numerator. Yes? So what will I have? I'll have 3 by 21 plus 14 by 21. Divide by 2. Yes. So this is going to be what? 17 by 21 divide by 2. I can write it this way. 2 can be written as 2 by 1. Yes. So 17 by 21, whenever we change division symbol to multiplication, this gets reciprocal. So we have what? We have 17 by 42. Yes, I hope this is clear to everyone. Netra, Sanjay Kohli, Kavyansh. Yes. Kavyansh, x plus y would be in the numerator. I think here it's difficult to write it that way. That's why it's looking like this. Wow, Pranjali. Mind is ready for Menti quiz? Wow, that's amazing. Okay, so this is clear to everyone. So I have first rational number between these two numbers. Now let's say I have to find out one more rational number between these two. What will you do? Same thing. Let's add them up, divide them by 2. But you cannot straight away add them up because they have got different denominators. So what will you do? You will make their denominators same, right? And then this becomes 6 plus 17 by 84. The step has been skipped. So if you have any confusion, please let me know. I'll show you the steps that were in the middle of it. Yes? Are you able to understand how we are getting 23 by 84 over here? Quickly, thumbs up, smileys. Yes, I can see that. Wow. Thanks, ma'am, for this amazing teaching. All my concepts are crystal clear only because of you. Thank you. Yes. All right, this is clear. Awesome. So we have learned. So this way you can find out any rational number between any two rational numbers using the mean method. This method is simple. See, it's good to learn new methods in math. So here we have 23 by 84, 17 by 42 between 1 by 7 and 2 by 3. Wow. This method is also easy. Now you have mastered it. Wow. Amazing. Well, this was the last concept of today's session. So we have revised the entire chapter, the entire rational numbers that we learned in different sessions, right? So I'm sure that all of you are clear with it. All the concepts that we have in rational numbers, all these concepts are crystal clear in your mind. Yes? New method is easier than the previous one. See, I told you. It only requires a little bit of concentration and practice. Yes, that is must. Yes, homework question. Don't worry, I'll show you. Now let me quickly take you through the homework questions. So, Pulkit, Lavjeet and Chanchal have a pizza. Pulkit had 1/4, Lavjeet had half of the pizza and Chanchal had 1/8 of pizza. How much pizza is left? So let me know the correct answer in the comment section after this session. And I expect that each one of you would answer to this. Yes? Quickly, thumbs up, smileys. Each one of you would answer to this question. Absolutely, Sonali. Yes, in just 40 minutes, we covered the entire chapter. And I think each one of you, it's clear to everyone, all the concepts. All right, all right, all right. So Sonali, after this session, you can again take a look at the homework question. Yes, and then you can solve it and share in the comment section your answers. Yes, Gungun, I know that. You always answer it. Thank you, Shaurya. All right, so as I told you that now we can connect on Telegram as well. And I hope that every one of you have joined it. Yes? Because it's going to be very interesting. You're going to get revision questions over there, session notes, which you always ask for. Revision questions, wow, that's going to be so interesting. There would be some interesting Sunday fun day facts also. Yes? It's good to enhance your knowledge, isn't it? Homework questions would be there. Quizzes, wow, the most interesting part. And session updates also you will be getting. Thank you, Kasana. Thank you, everyone. Yes, I hope you all have joined it. Awesome. So don't worry, we have got you covered. We have lined up many more sessions from every Monday to Friday. And another interesting thing, since summer vacations are going to start, so this break, let's recreate the summer goodness right here at BYJU'S. So please participate in 3 exciting mini-series on our academic channel. Science Project, Level Up, Explorers Club. Yes. Wow. Awesome. Me? Yes, yes, please, all of you, you can take a look at the homework question after the session and just share it with me in the comment section. Already joined. Wow. Awesome. Now let me give you a glimpse of the upcoming session. So our next session is on 11th May, that is Wednesday at 4 p.m. And there will be mega quiz for 6, 7, 8. Yes, for all the 3 grades. Wow, that's going to be so much interesting, right? All right, and there is a link for free trial classes as well. Please click on this link in the description and get all your doubts clarified instantly during the class. And please like, share, and subscribe so that you do not miss any new updates from us. Yes, it is for all the grades. Yes, absolutely, it is Menti. Wow. Aren't you all excited for this? Yes? For all the grades. Yes, it's a mega quiz. All right, so I'll see you soon. Thank you so much. Bye-bye.